Simply put, wind is the motion of air molecules. Two concepts are central to understanding what causes wind: air and air pressure. Air comprises molecules of nitrogen about 78% by volume, oxygen about 21% by volume, water vapor between 1 and 4% by volume near the surface of the earth, and other trace elements. Every time we breathe, the air we inhale is composed of about the same relative ratios of these molecules, and a cubic inch of air at ground level contains about 10-20 molecules. All of these air molecules are moving about very quickly, colliding readily with each other and any objects at ground level. Air pressure is defined as the amount of force that these molecules impart on a given area. In general, the more air molecules present, the greater the air pressure. Wind, in turn, is driven by what is called the pressure gradient force. Changes in air pressure over a specified horizontal distance cause air molecules from the region of relatively high air pressure to rush toward the area of low pressure. Such horizontal pressure differences of all scales generate the wind we experience. The areas of high and low pressure displayed on a weather map in large part drive the usually gentle ambient wind flow we experience on a given day. The pressure differences behind this wind are only about 1% of the total atmospheric pressure, and these changes occur over the range of multiple states. The winds in severe storms, in contrast, are a result of much larger and more concentrated areas of horizontal pressure change. Tornadoes are great examples. In June 2003, Tim Samras of Applied Research Associates placed a scientific probe in the direct path of an F4 devastating tornado near Manchester, Stoke. He found that the air pressure dropped by 10% of the total atmospheric value over the radius of the tornado. The magnitude of this air pressure change, and the very short distance over which it occurred, explains why the winds are so destructive in this phenomenon. Their molecules are very quickly accelerated into the very low pressure at the center of the tornado, where the water vapor contained in the air often condenses, creating the often visible condensation funnel.